Hello everyone, myself Prijafnavi. I am from CSMA section. Today my topic is about drift current in the subject engineering physics. Topic drift current. Introduction to drift current. Drift current refers to the flow of charge carriers in a material due to an electric field. It plays a crucial role in the operation of electronic devices such as transistors and diodes. Drift current is distinct from diffusion current, which is driven by a concentration gradient. You can observe the given picture. You can see hole, flow of currents, flow of holes and free electrons. Charge carriers in drift current. In semiconductors, drift current is mainly carried by electrons in the conduction band and holes in the valence band. The direction of drift current is determined by the polarity of the electric field applied to the material. Charge carriers experience collisions with lattices, impurities, and other carriers, affecting their drift velocity. Drift velocity. Drift velocity is the average velocity of charge carriers in response to an applied electric field. It is directly proportional to the electric field strength and inversely proportional to the effective mass of the charge carriers. Drift velocity is often much lower than the thermal velocity of charge carriers due to scattering mechanisms. Drift current density. Drift current density is the amount of charge transported per unit area time due to drift motion. It is given by the product of the charge carrier density, charge of the carrier, and drift velocity. Drift current density is a key parameter in understanding the electrical behavior of semiconductors. You can see definition. Current is a measurement of the amount of charge passing by a point per unit value of time. It is a scalar variable I unit ampere equation I is equals to Q by T. There are a few variables that can affect the size of the current in a traditional circuit where electrons are flowing. There are summarized in the second equation for current. Einstein relation. The Einstein relation relates the mobility of charge carriers to their diffusion coefficient in a material. It provides insights into the relationship between drift and diffusion currents in semiconductors. The Einstein relation is a fundamental concept in understanding charge transport phenomena. We can see the Einstein equation. dN by mu n is equals to kBT by E. Carrier mobility. Carrier mobility is a measure of how quickly charge carriers respond to an applied electric field. It is influenced by factors such as scattering mechanisms, temperature, and doping concentration. Carrier mobility is a key parameter in determining the performance of semiconductor devices. Using Hall effect measurement to determine mobility, carrier type, and carrier concentration. Relationship between drift current and drift velocity. In a semiconductor under an applied electric field, drift current arises due to the movement of charge carriers at a certain drift velocity. The magnitude of drift current is dependent on the charge carrier density, charge, and drift velocity. Understanding the relationship between drift current and drift velocity is essential for device designing and optimization. In the given picture, we can observe the holes, free electrons, and flow of electrons is moving on left side and flow of holes are moving on the right side. We can see the voltage also in the given picture. Impact of temperature on drift current. Temperature affects the scattering mechanisms experienced by charge carriers, influencing their drift velocity and mobility. Higher temperature can lead to increased carrier scattering, reducing the overall drift current in a semiconductor. Temperature also affects the intrinsic carrier concentration, which plays a role in determining drift current behavior. Applications of drift current. Drift currents is essential for the design and operation of semiconductor devices such as transistors, diodes, and solar cells. Understanding drift current enables engineers to optimize device performance and efficiency. Research in drift current physics continues to drive advancements in semiconductor technology. Conclusion. Drift current plays a crucial role in the behavior of charge carriers in semiconductors under an applied electric field. By studying drift current phenomena, researchers and engineers can improve the performance of electronic devices. Continued research in drift current is vital for the development of future semiconductor technologies. Drift current, drift electron diffusion, hole diffusion and depletion region and drift current. Thank you.